So you are programming a Siemens redundant system and you're trying to connect to another Siemens PLC device. You're given addresses of this kind, which correspond to the S7 protocol. You will soon find that if you are using a redundant system, the usual method for communications are not available. You will find that the S7 communication instructions are grayed out, and the documentation specifically states that those are unsupported instructions. Now, what can you do? Firstly, I will suggest to use another protocol if possible. It's going to be so much easier and to some extent safer, because the other option is to build your own S7 protocol client. And it's quite the amount of programming, and you will need to take responsibility for that code. In this video, I will give some pointers on how to make such S7 client. Firstly, you need to know how the protocol operates. Conceptually, it's simple. You establish a connection, and then you can make requests and receive answers. You can make requests for reading or writing data, among other things. The other important thing is to know that the S7 protocol is encapsulated atop TCP IP. So if you have a way of sending TCP IP packages, then you can send S7 telegrams. And you can see here that in communication we have a folder with open user communications, and basically this is TCP IP communication. We can use this simpler instructions to build more complex communications. Thus, what we need is a block that creates a TCP connection, then it creates an S7 connection, and then it sends requests for reading and writing and receives the responses. All of this through building and interpreting TCP IP packets. I will list some useful resources I have used to build the S7 client. The first one is this document, Examples of Open User Communication TCP. This one is particularly useful because it comes along with a library that allows you to make a bidirectional TCP connection. This is what we need, and it's important because there are already instructions that allow you to connect to TCP and send or receive packets, but not at the same time, and that's important. We need to have a bidirectional connection. Now, this library is also available in a newer version. It's called LCOM Suite. You can also find its documentation. I have not tested this version, but I assume it works, but it will be quite different in how to use. So, but you can check it out if you want. Also, just to make some emphasis on this, that you will have to program a state machine similar to this one atop this block, because you will need to have to manage the state of the connection and know what packets to send and what packets to expect. Also, a small thing is that this port, the 102, is required to make an S7 connection, but it is reserved on S7 PLCs. So what can you do is to open a different port locally, but remotely ask for this port. You can connect to it, but you cannot open it. So it has to be different in the source and destination. You need to do that. So something to note, if you use the old Open User Communication library, is that it seems to fail if you have a cyclic interrupt. It seems to forget the next cycle that it had data. So while it receives the data, it doesn't notify the surrounding code that it has received the data. So I had to add some variable that stores the data until it's the notification until it's actually read. That's a small modification that I did. Also, what you need is to modify the part where you receive data, this part. There was a different code in this section, and what I did is basically copy the whole packet to the output array without much processing, because I will do it afterwards. So you need also to modify this part. For the next part, when you already have a TCP connection and you want to establish an S7 connection, you have to send the appropriate message. Now, to know how to build such message, you can check existing projects. Existing open source projects like Snap7, which I think is the oldest and biggest one, I'm not sure. You can see how they do it in the code. However, I think for this one particular project, the code is hard to understand. So I personally like to read the Rust7 and Python Snap7 projects code in order to see how they do it. So the things you want to look out for is how they build the packets. For example, I have here the function connect DSAP, which basically does these two first steps, the ISO handshake and the PDU negotiation. Now, you can find here in this array, this is the message that is being sent. And you will find that many of them are constants, they're values that never change, and there are some variables that change depending on the configuration. You can see how these variables are constructed depending on the specific version of the PLC you are using. Here, no, you can read the code and see how it's built, how this variable is being calculated. Also, you can see here that the PDU negotiation telegram, how it's being built. Now, for each one of these messages, you receive a response. And you can check the response. It's not absolutely necessary, but it's good practice. I have found that if you send the wrong message, normally the connection is terminated. So you don't, you know if you have done something wrong. But it's also good practice to check now if the message is correct. No? Now, the answer to the S7 PDU negotiation telegram has information of what is the biggest message you can send. This is not that necessary because, well, it depends on your application. Here it has a default value, and normally the PLC will accept that value, that maximum length. But well, it's something to consider for your application if you need to take care of that. Since I need only a few variables, it definitively fits in that amount of bytes. So this is an example of how I have implemented it. I have stored here the templates for the message, the handshakes, and the requests, the read and write requests. Here we can see that some parts are 0 because I had to modify later depending on what message I want to send, what requests I have to send. And here you can see the state machine I have built to manage the connection. It's the same thing in this as the diagram we have seen. We have, no, it's here. It's here. This is the library. This is my code, how I connect to ISO, and then I wait for that connection to be successful. Then I connect to S7 and wait for that connection. After I am connected, then I can send and receive packets and can make requests for reading or writing. And here you can see I have to modify the template in order to receive what I want or to send what I want. You will need also to calculate the total length of your requests, in fact several times. Here it's the total length of the message, and here is the size of the payload, the size of the data you are appending to the message. And this is in general terms what you need to do. If you really need the code, I can bust it into a public repository, but I would recommend you to make it your own, because I really don't want to take responsibility because this is kind of hard code and I have not much experience with networking code, so this is quite rough around the edges. But I can bust it if requested.